Okay, so we're gonna start or continue with the notes at this point, proving the cosine of a sum. Having proved that the cosine of a difference is cosine u cosine v plus sine u sine v. First off, we need to make a connection between the two. That means figuring out a way to convert the cosine of a sum to a cosine of a difference, so I can use the identity previously proven during class. In order to do that, we need to realize that cosine is an even function, so I can go ahead and rewrite it as cosine of negative u plus v, and then distribute the negative onto both angles. Now I'm actually looking at the cosine of a difference, and I'm going to go ahead and make sure I highlight or underline the two different angles I'm dealing with. The first angle is negative u, so including the negative, and the second angle is all of v. Now we can apply the cosine of a difference identity, so it's going to be cosine negative u cosine v plus sine u sine v. Sorry, should be sine negative u sine v. With a little bit of manipulation, we can rewrite cosine of negative u as cosine u, cosine v, and then sine is odd. Take out the negative minus sine u sine v. With this step, you would have completed the proof, and you have cosine of u plus v as cosine u cosine v minus sine u sine v. Okay, moving forward to the next page. We have cosine of a sum is equal to that, and then we're going to prove sine of u plus v. I'm going to go ahead and write down what it should turn out to be and try to keep that in mind. So sine of a sum is sine u cosine v plus cosine u sine v. Okay, now we're going to go ahead and derive that using the other identities we've proven. Okay, you don't have to use cosine of a sum. You could use the cosine of a difference instead. So I'm going to write that down over here. That's the one we proved in class using the unit circle. So I'm going to do cosine u cosine v plus sine u sine v. You can use any identity you've proven to derive new ones. Okay, so over here, I'm going to go ahead and rewrite sine of u plus v as a cosine function. So we know sine and cosine are cofunctions, so I'm going to rewrite it as cosine of pi over 2 minus u plus v. Okay. Then I'm going to go ahead and rearrange the terms a little bit. So cosine of pi over 2 minus u minus v. And again, rewrite that as cosine of pi over 2. I'm going to do a little bit of regrouping and then minus v. Okay, because I need to make sure that these two quantities include each one of the two angles. I don't want to have u and v combined. I want to have u as one quantity and v as the other quantity. Okay, now going back to cosine of a difference, I'm going to use the difference identity. So it's going to be cosine of the first angle, pi over 2 minus u, times cosine of the second angle, v. So this is going to be plus sine of pi over 2 minus u sine v. Okay, now keep in mind we're trying to prove that sine of u plus v is equal to sine u cosine v cosine u sine v. So we're kind of almost there. This is still cosine cosine sine sine, right? This is still cosine cosine sine sine, but with a little bit of imagination, we can get to where we want to go. So cosine of a complement is really sine of the angle itself, cosine v. So using the complementary angle idea, plus sine of a complement is cosine of the angle itself, sine v. Let's see. So now we've got sine u cosine v plus cosine u sine v. And we're done. Next one is sine of u minus v. I'm going to go ahead and turn this subtraction into addition by actually just adding the opposite instead of subtracting v. So I'm going to rewrite this as sine of u plus a negative v. Again, if you want to do double parentheses, it might actually be easier. Then moving forward with sine of a sum, which we proved in the previous example. So it's going to be sine u cosine negative v plus cosine u sine negative v. All right, and then we manipulate this a bit. So sine u sine, nope, cancel that one. Cosine is an even function, so I'm going to write it as cosine v plus cosine u. Sine of negative v, that's an even function, sorry, an odd function, so we can actually take out the negative and place it right here instead of the addition sign. So I'm going to go back and fix that. So negative cosine u sine v. And that completes the proof.